Hey, what's up, everyone? Welcome to this new live stream called What's Up in the iOS Community. So, let me tell you a few words about the concept of this live. It's basically a newsletter in the form of a live stream, meaning that I'm not just going to send you the links to a few articles, I'm actually going to read them and discuss them with you. A few words on why I came up with this concept, and the reason is that I came to realize, like 1 or 2 weeks ago, that most of the articles that are published on the blogs of iOS developers, they're of course a fantastic source of knowledge. They are actually and arguably one of the best way to learn and improve your iOS skills. But at the same time, they are not always very accessible to people who are just getting started. Most of the time, these articles are written with the assumption that the reader is already familiar with Swift and iOS, and that makes total sense. And anyway, you cannot write an article that will work, that will be accessible to everyone. And so I thought, why don't I cover some of these articles, discuss them, explain them, basically try to make them as accessible as possible. And so that's why we are here on this video. So if you're watching live, please feel free to ask any question you have, say any remark you have in the chat, because it will make it feel so much more alive for people who are watching the replay, and of course because I will do my best to try and answer your questions. Did I have another thing to say before I get started? Actually, I don't think I do. So yes, last thing I had forgotten. In the description of the live or of the replay, you have the links of the articles I'm going to cover. If you're watching live, there might be some articles I will actually not cover because I don't yet know how long it will take to cover an article in this format, and I don't want this to last for like more than 2 hours because I don't think it makes sense. But you have the links in the description if you want to check out the articles on your own browser or whatever. And with that being said, let's get started. So for the first article, some of you might have already recognized on which website I am. I am on Antoine Vanderlee's website. So if I scroll up, we can see him. So it seemed only fitting to start this new format with an article from Antoine because Antoine runs one of the most popular email newsletter out there in the iOS community. Actually, it's very possible that some of you have known this channel thanks to him because at the beginning, when I got started, he shared a lot of my videos on his newsletter. So it felt only fitting to start this format with an article from Antoine. So this first article is called Task Groups in Swift Explained with Code Examples. So this is going to talk about Swift concurrency, what is sometimes also called the async await mechanism, which is Swift's, I was about to say new, but it's already been there for 2 years, but Swift's most recent way of dealing with asynchronous code. So let's start reading. So task groups in Swift allow you to combine multiple parallel tasks and wait for the result to return when all tasks are finished. They are commonly used for tasks like combining multiple API request responses into a single response object. So here we're going to be talking about a mechanism, an API that allows you to combine several asynchronous tasks together into a single result. So read my article about tasks first if you're new to them, and make sure you've read my article covering async await since it's the foundation of task group today. With that in mind, we are ready to jump into the details. So I'm not going to read these two articles, but I will try to contextualize things as much as possible as we progress in the article. So what is a task group? You can see a task group as a container of several child tasks that are dynamically added. And so this work dynamically is going to be important. Child tasks can run in parallel or in serial, but the task group will only be marked as finished once all its child tasks are done. So why do I say this dynamically added is going to be important? It's because if you've already used async await, you might have seen that there is another mechanism called async let that lets you create several tasks in parallel, except that this mechanism that is simpler to use than task group only works when you have a static number of tasks to run. So what do I mean by static number of tasks? An easy way to define it is to say a static number of tasks, meaning that you can declare a variable for each of the tasks. So that works if you have 2 or 3 or 4 web services to call, and that number is always the same. But as we're going to see in the example just below, if you need to make a call for each element of an array, that doesn't work because that number of tasks has now become dynamic. So I'm trying to contextualize things as much as possible. So when you use async await, if you want to do just one network call, like to fetch data from one API, you just await the result of an async call. If you have a static number of calls to run in parallel, you use async let, so second level of complexity. And when you have a dynamic number of tasks that you need to deal with, so we could say the third level of complexity, then you need to use task group to run this dynamic number of tasks in parallel. And tasks is quite a difficult word to say. So a common example could be downloading several images from a photo gallery. So I guess this is the typical example you will find on almost all articles talking about task groups, because if I were to write one, I would choose this one because it's the one that is the most real world. Like if the point where you need to use a task group in an iOS app is often to deal with downloading images for like you have a list, the cells have an image, you need to download the content of the image. So what does the code look like? So we await the result of a with task group. We pass a parameter which is UIImage.self. So it seems like that argument is the type of the result of the individual tasks. And then we pass a closure that takes the task group as its argument. And inside, we have our photo URL. So it's done by fetching a first service. Could be a web service, it could be a database, but at least something that is async. And then we iterate over the photo URLs with the for in syntax. And this is where we start using the task group. We add a task to the task group. And so we could say we enqueue in a way, even though it might not be a queue, but we add something new to the task group. And so here we add the fact that we await the download of the photo. So this is the line of code right here that allows us to add a task to the task group. Remark that for now we're only dealing with adding to the task group, and we haven't talked about how we deal with the result. So this is only half of the code, I guess. Still going to let the code be displayed. So we first downloaded the gallery's photo URL list in the above example. So this line right here, note that this task doesn't link to our group, and with that doesn't influence the state of the task group, because indeed here we were adding tasks to the task group, but here we have started this task to list photo URLs completely independently of the task group. And so basically this task is part of the creation of the task group rather than of the task group itself. Okay. And so I see a comment. So is it about downloading in parallel? So it's about downloading a dynamic number of things. It could be serial and it could be parallel from what we've read earlier in the article. So we will see like what will be the precision about this topic. So I think I left here. So secondly, we iterate over each photo URL, so this line right here, and start downloading them in parallel. So this seems to suggest that at least by default, task group works in parallel, which kind of makes sense because async let also works the same way. So I guess as soon as you have added a task to a task group, it is starting, but we will see if the article confirms it. And finally, the with task group method, so right here, will return once all the photos are downloaded. So basically, what this does at a very high level, it kind of it does, we could say, a end so of all the tasks, meaning that it's going to wait for all of the tasks to be completed in order to return the result. Let me read the chat a bit. So Diego says, hello from the USA. Hey Diego, nice to see you here. And we have Rashesh saying hi from India. So super cool that we see two very separate continents and time zones on this live, and super cool to see that you seem to be enjoying this new format. So we've seen how to create a task group, then the article walks us through how to use a task group. So you can create group tasks in several ways, including handling errors or returning the final collection of results. They're a more advanced alternative to Asynclet and allow dynamically adding tasks. So that's what I was referring to. So if you want to learn more about Asynclet, you can read the article Antoine has already written about it. Okay, let me take a look at the chat. Hello from Canada. Hello from Armenia. So we really have countries all over the map. I guess we're just missing someone from Japan, for instance, in order to have both extremities of the map. But this is always amazing to see that you can reach so many people just from your home, basically. That's always it never gets old, basically. So, returning the final collection of results. The first example shared in this article covered combining tasks without returning the final collection of images. We could rewrite that example and return the collection of images instead. Okay, because I guess in that case, download photo was a method with a side effect. So I guess it would append to a dictionary, maybe do something like that, insert a value and a key to a dictionary, and so there was no need to manually check the result. But in this new example, it's the case. So we still create the with task group, and we still have the images that will be returned by the task group. Okay, we can see that this time we create a task group of UIImage.self. So each task will still return a UI image, but the task group itself will apparently be returning an array of UI image, which makes sense given what we've read so far. And we still pass a closure that takes the task group as its argument. So we still make the network call to get the list of photos URL. We still iterate over the photo URLs. We still add a task for each photo. So these lines are still the same than in the first example. And then here we are going to get the result. And so we create the array of results. We do for await result in task group. So for await in, it's kind of like for in, except that you do it when you are iterating over an async sequence. And so, just like an await can pause, it can create what Swift calls a suspend point. Well, here is the same thing. Before iterating to the next element, there can be a suspend point. And the way it's gonna work, and I guess it's explained later in the article, I'm getting maybe a bit ahead of it, but it's that the task group here, you will be able to iterate over the result it produces with this syntax. And so we have the result and we append it to the array of images. Since I know a bit about task group, I know that there is a trick in this code, but I guess the article is going to discuss it later, so I'm not going to spoil it for now. But there is a subtle bug in this code. Okay, we define the return type as a collection of images. This is going to let the code visible when I'm reading the commentary about it. So we define the return types as a collection of images using an array of image. After starting all child tasks, we use an async sequence to await the following result and append the outcome image to our result collections. So this is what's happening right. No, this is what's happening right here. I got confused because result is not the name of the variable right here, but this describes what's happening right here. And so why can we iterate over for await in, and it's a very smart thing for Antoine to point it out, because actually I hadn't realized it until I read this article, but until I saw Antoine's talk at in Singapore like 2 weeks ago. So I guess the conference talk inspired the article. But what's really great with async sequence is that what's really great with task group is that task group conforms to async sequence, and this is what allows us, for instance, to do a for await in over a task group to get the results of the task group. Let me read in the chat. So you're saying, will this live remain on YouTube? Yes, the live will remain on YouTube. The replay will be available, and it will be available through the same link than to access the live. So let's see what we have next. So this is Discord right here. And so what's happening? Yeah, we can use a reduce, because most of the methods of sequence are available on async sequence. And so just like you can reduce over an array. So reduce is basically the equivalent of the for loop, but in the functional programming realm. I have a video about how to use reduce on my channel. It's one of my first video. So if you watch it after, you will probably like notice a difference. At least I hope you will notice a difference. It will mean that I have made some progress since then, but I have a video about it. Here, I think it's interesting to show it. Honestly, I would prefer this code over that code. I used to be very enthusiastic about functional programming, but I feel this code is more readable than that code, to be honest. But it's true that since task group conforms to async sequence, you can do a reduce on it. Maybe I don't want to say more useful because it's a bit judging, but you can also do a map, for instance. So it means if you have your task group and you want to transform the results of the task before you use them, you can call map on it. And that's also a great way to leverage the fact that task group conforms to async sequence. Diego is saying, any plan on new courses? I've been dying to find a good course on advanced topics. I've never sold a course. It's not in my plans for the near future. Like I never say never, but for now it's not in my plans in the near future. But for good content, I can recommend like Hacking with Swift has a lot of good content, and they have Hacking with Swift Plus with like some exclusive content. I know Sean Allen also sells courses. I never watched them, but I have no reason to like doubt their quality. So it's the two I could recommend. Will there be a Q&A at the end? If you want, there can be. That's a good question. If you have questions that are like off topic from what I'm saying, we can do a Q&A at the end. But if you have a question that is even remotely related to the article, please ask it. Don't hesitate to asking. It will be useful both for you, but also for all the other watching. All right, let's see. So we've just covered this result. So then other operations like map and flat map can also be used. Perfect, that's exactly what I was saying, allowing for flexible solutions to create the outcome. Finally, you can use the collection of images and continue your workflow. And that's a great thing, because once you have a collection of images, you are back to just having an array, and so you can manipulate it just like any other array, so you are out of the asynchronous world, we could say. Okay, now it talks about how to deal with errors, because async code often comes with errors because a lot of async things, they are async because they depend on external factor. And when you depend on external factor, well, you are also prone to errors that you cannot control. And so the two tend to go hand in hand. So it makes sense to talk about it right now. So it's common for image downloading methods to throw an error on failure. We can rewrite our example to handle these cases by renaming with task group to with throwing task group. So it's another method that is part of Swift. And so you can see that now basically the try keyword has been sprayed over the code. So we do a try await because with throwing task group can throw. Same thing here, list photo URLs can throw, so we do a try, and same thing for the task to download an image. And here there is also a try when you try to access the result, which I guess allows us to like have a finer control over the error, I guess, because we're going to see, I guess it's explained afterward, but if this here throws an error, we have the possibility of dealing with the error here, and we are not forced to just passing it on to like to the caller. Like if a network call fail and we have like a way to recover, either by ignoring that network call, by providing a default value, that kind of thing, we can deal with it, and we can avoid all the tasks failing, being reported as failing just because one of them failed. You're asking, is there a similarity with Combine? Great question. I've been asked to make a video about that recently. So I would say Combine, it's about at its core, and it's what they say like in the overview of Combine. Combine is about dealing with values over time. So it's about asynchronous code, but asynchronous code that produces values over time. Whereas Task Group is more about how do you orchestrate asynchronous calls that will return only one value. So I would say Task Group only deals with a subset of the problems that Combine deal with. So it's less powerful, we could say. However, since it's more specialized, it also has a syntax that is maybe easier to understand, and like it's a lower step to start using Task Group than it is to start using Combine. Okay, so let me read the comments about the code. So note that we added the try keyword before each async method since we have to handle potentially thrown errors. So this is how error handling works in Swift. On that topic, I also have a ton of videos from the early days about how this error throwing mechanism works in Swift. And so the outcome will now be a throwing task group. So what's returned by with throwing task group? That will return the result of images. No, actually, it's this thing here, the task group, that will return the return of images as long as there is no thrown errors. So how do you fail a group when a child task throws? In the above example, our group wouldn't fail if a child task throws an error. Okay, why is it the case? That's interesting. So it seems like if an error happens, is it ignored by default? That's very interesting. So to make that happen, we need to change how we iterate over the outcome results by using the next method. Okay, so apparently, maybe when you do like this, it automatically like ignores the failures. The next method receives errors from individual tasks, allowing you to handle them accordingly. In this case, we forward the error to the group closure, making the entire task fail. Any other running child task will be cancelled at this point. Okay, so this would seem to mean that this try right here, like, doesn't necessarily like throw an error. It could be the case. Like one of the things that I personally not always like about async await is how it can be like unsafe by default, whereas like Combine will force you to deal with memory leaks by default, will force you to deal with errors by default. So I guess yeah, that's there are some gotchas when you use task groups, definitely, because when you look at that code, when I look at that code, I have no reason to think that errors will not be like sent all the way up. But okay, at least we have the syntax to use when we want that behavior. All right, avoid concurrent mutation. You need to realize you shouldn't mutate a task group from outside the task where you created it. For example, please don't pass it around and add child tasks to it from another task. So you don't want to have a task get the task group as an argument and then add more tasks. For example, that's what I just read. In most cases, you should be warned by the Swift type system when you do, since mutating operations like this can be performed from a concurrent execution context like a child task. So concurrency is still a difficult topic. Swift concurrency tries to make it as simple as possible, but it comes at the cost of certain assumption about how your code behaves, and that includes not modifying the task group from inside one of its tasks. So you cannot basically like Imagine like you want to do some kind of recursive download. So you download you create a task group, you create tasks to download all of the top level elements. And then each result of each task would create new tasks for all the child elements and would add them to the initial task group. That doesn't seem to be recommended. Cancellations in groups. You can cancel a group of tasks by canceling the task it's running in or by calling the cancel all method on the group itself. When tasks are added to a cancel group using the add task, they'll be cancelled directly after creation. It will stop its work directly depending on whether that task respects cancellation correctly. Optionally, you can use add task unless cancelled to prevent the task from starting. That's one of the important things of how tasks work in Swift concurrency is that the cancellation of task is called cooperative, meaning that when you cancel a task, when you call cancel on a task, what you're actually doing is that you are setting a flag to true. The task can check this flag by calling something like task.check cancellation. I don't remember the name by heart, but that's the general ID to it. And if the task has been cancelled, it throws a cancellation error. But the task isn't forced to check, and the task only does it if it wants or if it is safe for it to do so. The general idea behind it is that if Swift were to force canceling a task, maybe the task is in the middle of doing something important. Maybe the task is in a critical section. Maybe the task has opened a file, and if it were to be cancelled while it is writing to that file, it would leave the file in a corrupted state. So that's the reason behind it. But having this system also create its added share of complexity. Like everything with software design, everything is a compromise. When you optimize for some things, you de-optimize for other things. Okay, creating a tasks group result builder. So this part, because I haven't read the article. I didn't say it, but I haven't read the articles I'm going to comment beforehand because I wanted to like comment them live with you. I know the blog, so I know they are good quality, but I haven't read the article. However, I've seen Antoine's talk, so I know what he's going to talk about right now. So first, let me say a few things about result builders. So result builders, it's a feature of Swift that was initially called function builders. It basically it's basically one of the building blocks of Swift UI. There are 3 building blocks to Swift UI. There is combined, but it's under the hood, we could say. But there is the property wrappers that Swift UI uses extensively, and there is result builders that Swift UI also uses extensively. And this is what allows us in the body, when we want to have several views, like in a VStack, to just put these views one after the other without having to put them into an array. As with everything in computer science, there is no magic. Something does put the views into a collection, and the result builder is tasked to do it. So result builders is this mechanism in Swift that you can use to create some nice little domain-specific syntaxes. And so here, the goal is to show us how to create a result builder to simplify the task group syntax. So remembering how to bundle tasks together in a group with the earlier shared code examples can be challenging, because indeed it's not the most intuitive code in the world. Honestly, like if I need to write this tomorrow, I will probably look for an article like that and copy paste the code snippet and build from that. You have to call the add task method, await the result, and append it to a collection before you get the outcome result. Instead, we can create a custom result builder, allowing us to rewrite the above code as follows. So I'm going to try and explain it as much as I can. If you want more detailed explanation about how result builders work, I have some videos also on my channel with like a few advanced examples. Like I have a video where I show how you can use a result builder to build like some kind of nice testing syntax that could be interesting. So let's see how result builders are used here. So the part that changed is here, because you can see here we no longer have the task group passed as an argument, and of course, since it's not there, we cannot call anything on it. But we are no longer calling task group dot add task. We just create a task inside the for loop, and by some kind of magic, the task still gets added to the task group. And of course, this is what a result builder does under the hood. So there is no detailed explanation of how this result builder works. Since I'm already half an hour on this article, I'm not going to go into the detail because it's also like more advanced, and so not the thing that a beginner would want to have a look at first. But this approach is very interesting, so I can only recommend that you take a look at what this custom result builder looks like. But be aware that it is an advanced topic. It can be a bit weird because a result builder, in some aspects, you can see it as a very simplified version of a compiler, because at its essence, a result builder turns how should I phrase it? It's going to turn like instructions like this into data structures. So kind of like what a compiler does, and on a very like high level picture. So it can be weird because result builder, it's a class with only static method. It seems very weird, but it's very interesting. So if you're into advanced topic, I recommend that you check it out. And I guess we are getting near the end of the article. So continuing your journey into Swift concurrency. So the concurrency changes are more than just task groups and include many new features you can benefit from in your code. Now that you've learned about task group, it's time to dive into other concurrency features. So it's basically links to other articles by Antoine. So there's the one we've just read, one about Sendable, which is a topic that is going to become even more and more important because the next version of Swift 6, will be much more strict about this. But basically, Sendable is about saying what kind of data is safe to share between tasks and which kind isn't. Async sequence, how does it work? Async throwing stream and async stream, very useful. Async stream is what you use when you want to turn code, like for instance, if you want to turn, I guess, a publisher from Combine into an async sequence, you would use async stream. Actually, you wouldn't need to because there is already a method to get an async sequence from a publisher built in. But if you wanted to turn an observable from Eric Swift, you would probably use this, even though Eric Swift probably already implements this, but under the hood, it probably uses async stream. Task explained, async await explained. So basically, if you want to learn more about concurrency, just check out these links. It's great content. Let's just read the conclusion. So a task group allows you to dynamically bundle a set of tasks and wait for their outcome while they execute in parallel. So that's basically the one sentence. If you need to remember what a task group is, that's the one sentence. And the really important word is dynamic number of tasks. That's the most important thing. You can handle errors and cancellation, but you must be careful to use the next method to forward failures. That is something I have learned right now, like reading this article. I didn't know that before, so great job to Antoine for mentioning it into his article. And it shows that this API can have its pitfalls. The outcome can be returned once all tasks are complete, allowing you to bundle request responses. Okay, so I said at some point there is something potentially buggy in this code right here, and in most of the code that iterates over the task group. So since the article didn't cover it, I'm going to tell you what it is, and it's the fact that when you iterate over the result of a task group, you get the results in the order in which the tasks completed, and not the order in which you enqueued the task. So it's important to have this in mind because, for instance, here you had an array of URLs. There is no guarantee that the images will be in the same order than the URLs were in the array. So you need to be careful about it, basically. But you can find ways around it, which often boils down to use some kind of dictionary to associate a key and the value that is the result. The key would be the URL and the value would be the result. That's an easy way to solve it, but that's something to bear in mind. And it's one of the gotchas of this API because there is nothing in the API that is warning you when you are writing this code. So I see a comment that says Wilfried says equivalent of combine latest in combine. Expect it is dynamic. Not really the equivalent of combine latest, because combine latest is kind of like a OR, we could say, because it returns the most recent result of several like streams. Here it's more the equivalent of a zip, because it's going to wait for all the tasks to have completed to return. But on a big picture, you're absolutely true, because combine latest is also on the big picture about how do you combine several streams of events into a single stream of events. A question that is a bit out of topic, so I'm going to say it in English. So I would like to learn iOS dev. What do you recommend to start between UIKit and SwiftUI? Thanks. I would say SwiftUI, because it is the most simple for someone that is getting started. But as soon as you feel comfortable, do learn about UIKit, because it's still a very important part of iOS, and it's still the cornerstone of many iOS apps these days, and it will probably still be for the few years to come, at least. All right, we are done with the first example. So we have like 30 minutes per article. So yeah, I mean, when you want to like go over it and give explanation, that's normal. So let's move on to the next article. But I can already say that we are not going to cover all the articles I had put, because my voice is not going to carry me through 2.5 hours of reading articles. That's true. That's true. You're right. Combine latest won't output a value until all publishers have published a value. I was more thinking, I guess, the case where like there is an initial value for some of the publishers. Like when I think of combine latest, I always think like, like you have a form and you want to check like that password and password confirmation are the same. So that's why I kind of see it more as an OR, and zip more like end. But you're absolutely right on that one. Okay, so second article, we're on a new blog. I'm just going to move the screen around because I don't want to cover the text too much. So we are on the blog of Sarun W. Great blog. I often see his articles being shared on Twitter, so I wanted to pick an article from his blog, and it was about how to sort by multiple properties in Swift. And I chose it because I was intrigued. I still haven't read it, so I'm going to discover it. But since like one of my first big projects in the AS community was about how to use the key path syntax to do data manipulation that included sorting by multiple properties, it reminded me of that, and so I thought it would be a very interesting topic to cover, because depending on how you do it, you can introduce topics like type erasure and that kind of things. So potentially great article when you are new to Swift and you want to start learning advanced concepts. All right, so let me scroll. Let me check that everything is visible. No, everything is not visible. Good thing I checked. Okay, we're good. So sorting is easy if you do it over one criteria or a single property. Swift already has a function for that. Here's an example where we sort an array of int. So let's numbers, so an array of numbers, and let's sort in numbers, and we do that by calling the sorted method, which takes a closure with two elements of the array, and we need to say which one is the smallest. And then basically you need to say whether the left hand side is smaller than the right hand side, and the sorting algorithm uses it to sort the elements of the array. But in this case, you are sorting only over one property, over one dimension. But there would be a time where you need to sort things over multiple criteria or properties. To demonstrate this, let's create a struct as an example. Here we have a simple blog post struct with a title of the post and two statistic data points, page view and session duration. So it's really like your most basic struct in Swift. What's interesting is that we can see there are several types. There are strings, ints, and doubles. So I guess this means we're going to talk about type erasure at this point, and I'm really excited to see how he explains this topic, because it is a bit of a challenging topic to explain. All right, and here is some sample data. So we have some blog post created by some, not by some people, it's the title, it's not the author, but we have titles, page views, session, durations. All right. If you want to see which posts perform well, you might start by sorting them by page view. But as you can see, many posts aren't that popular and have the same page views. This is where, of course, sorting over several elements becomes useful. It's when there is an equality on the first property, then you can use the second property to sort the elements. In this case, you need another criteria or property to do a further sort. This kind of multiple properties sort is what we are going to talk about in this article. There are a variety of ways to tackle this problem. I will show the most basic approach without any advanced concept. You can make it as advanced as you want once you understand the basics. So what is multiple criteria and properties sorting? Multiple criteria sorting means a sorting in which we compare the first criteria, and only if the first criteria is equals, we then go to the next one. We do this until we find a non-equals criterion. I would also add, or until the list of criteria has ended. Like when you no longer have a way to compare, you're like, okay, well, it's going to be in the order that it is right now, if your sort is a stable sort. And just want to define it. When we say that sorting algorithm is stable, it means that it preserves the order of the elements that are equal. Whereas a non-stable sorting algorithm will probably can do anything. Like it can preserve the order or not, and it really depends on basically like on how the algorithm went through the sorting process. Pseudocode will look something like this. So we have our sorted objects. We do object.sorted. We have the left-hand side and the right-hand side. And so we iterate over the criteria. So basically, it's a way to get the properties. Okay, so yeah, we have a sequence of properties. So it's the property on the left-hand side and on the right-hand side for the first test, then for the second test, etc. And if there is an equality on the first property, we continue to the next one. And finally, when there is no equality, or when the list has ended, we return whether the current property is greater or less than. We return whether the left-hand side is less than the right-hand side for that criteria. So either the first criteria where there wasn't equality or the last one in the array. So this is what the algorithm looks like. It always looks a bit weird because it's not the kind of code we are used to writing in iOS. This is more like low-level code, but the bottom line was said just above. You iterate over the properties that you are going to compare, and as soon as you find a property for which there is no equality, you use that one for the comparison. And if you've reached the end of the properties, then you use the last one because you don't have a choice. But anyway, since it's like equal, it doesn't really matter. So I guess that's what was explained. We look through the list of criteria starting from the most important one, the first one. So here, if the order criteria are equals and we can't decide the order, we move on to the next criteria. So right here. And 3, if we can decide the order between two objects from the criteria, we stop and return the result. So right here. If you have a hard time understanding the pseudocode, don't worry, I'm not a pseudocode professional writer. The following example should make it clearer. So sort an array of objects over 2 fields. We will use the same scenario mentioned above. We want to sort a blog post based on performances. Our performance decides by the number of page view, and if blog posts have the same view, we use session duration. Here is a blog post struct and sample data that we used in the previous example, so we've already seen this. Sorry. The way we measure performance can be translated into this code. So let popular post, so blog post.example, so this is the static data, sorted. We have the left-hand side and the right-hand side, and it does if left-hand side page view equal right-hand side page view, then it uses the session duration. Otherwise, it uses the page view. I'm not sure why it's in the other. It's doing like it's sorting in reverse order by doing that. I'm not sure. I'm not sure why. Could be a typo. Could be explained later. And so yeah, here on line 1, here that's basically like what I said. And what's important to note is that it's kind of like the previous article in a way. Like I didn't plan for it, but there is this common thread of like how do you go from a static number of things to a dynamic number of things. So before, as I was saying, when we have a static number of tasks, we can use async let, and when we have a dynamic number of tasks, then we need to use task group. And here in the static case, when we only have two properties to compare, we can use this code, which is simpler than the pseudocode, but it only works with two properties. And I guess then the goal will be to see how do we deal in Swift with having n possible properties to sort. And here is the result. So it's order indeed in decreasing order. Yes, it says because he said that he wanted to sort by the performance. So that's why he did the test, he did the comparison in the other way. So first, it's sorted by decreasing page view, and when two page views are equal, then it's sorted by decreasing session duration. But you can notice that session duration is only used when the page views are equal, because, for instance, when we look globally at all the data, the session duration are absolutely not in decreasing order. However, for a given value of a page view, then the session duration are in decreasing order. So that all works as expected. So sort an array of objects over 3 fields. As you can see, it is very easy to perform a sort by 2 criteria. Let's increase more criteria into an equation. If blog posts have the same performance, we will sort them by name. So here it's adding a few more blog posts to have like more data, because of course as you add criterion, you need more data in order for the result to make sense and to demonstrate that indeed it does work. So there is no difference between 2 and 3 criteria. We can use the same logic as before, but we can see that the code has grown in complexity, because basically we need to hard code all of the code paths. Basically what we are implementing here is a decision tree, basically. And so if the page view are the same, then if the session duration are the same, then we use the title, else we use session duration, else we use the page view. So we can see, like, if we are sorting in decreasing order by these properties, we can see the properties first being mentioned in the if, and then being mentioned in reverse order in the comparison. And the title is not mentioned because since it's the last one, you don't have to test for equality, but it could have been added to the code. It just wouldn't have changed anything to the result. So we add another if to check if blog posts have the same session duration, and sort them by title if they got the same number of page views and session duration. And so the results are here. And so if the page views are the same and the duration are the same, then it's being sorted by titles. And we can see that titles are in increasing order because it is the operator less than that was used, whereas for the other, it was the operator greater than. Let me take a look at the chat real quick. Yes, so you said most popular would be first then. Exactly, because it was in decreasing order. And using guard would have made that code much simpler already. That's very true. Yeah, that's very true. Indeed, it would have probably like simplified it, because it would have reduced the indentation, the level of indentation, or what's sometimes called also like the word is the cyclomatic complexity of the code. It's an awful word, but you will find it in most linters. And what it means, cyclomatic complexity, is the number of distinct code paths inside a given function. So like you see, like here you have like one code path when you do that, then 2 because you can go into this if, 3 because you can go there, etc. So actually, I'm not sure if guard reduces that complexity or if it just like makes it more readable. I'm not sure, but at the very least, it would have made it more readable. So what's the problem? We can use the same logic for 2 and 3 criteria. The only problem is that the more criteria, the more nested if else you will need. Yeah, we have started to catch up on that trend. Here is an example of multiple criteria which might lead to pyramid of doom. And you can notice that it's not a dynamic number of criteria. It's a static, maybe very large, but still static number of criteria. I saw a comment about Flutter, but I will answer it at the end of this article. So sort an array of objects over n fields. To solve the pyramid of doom, let's bring back the pseudocode we saw earlier. So that's the pseudocode we saw earlier. The code above is not the only way for this kind of problem, but the key should be similar. The key is we pack criteria into a collection where we can loop over. So what you were mentioning, Wilfried, like an array of tuples. So we still have the blog post. We have a type alias r in increasing order, which is a function that takes 2 blog posts and returns a bool. So you can, basically what it's trying to do, and he said it at the beginning, is to solve the problem with only the basic building blocks of Swift. Some of you that know about KeyPath might be thinking, yes, this is a good place to use KeyPath. You can use functions because at its core, a KeyPath is just a literal syntax for a getter function and a setter function. So we have this r in increasing order. Then we have the method sorted, and so we have the predicate r in increasing order. So predicate, I just want to define the word because that word can be extremely scary, but it's only scary because it comes from math. A predicate, it's a Boolean condition with a variable. So basically, a function that takes argument and returns a Boolean is a predicate, just because that's the name of it. It's not more complicated than that, at least not for the use that's going to be made of in this video. And so we have the predicates. So first predicate is whether page view is greater in the left-hand side than on the right-hand side. Same for session duration, same for the title. So these are our sorting predicates. And then iterating over the predicates, we say, okay, if the predicate isn't true for the right-hand side, so if it isn't true, like, that's interesting. Actually, I'm going to like read it with the comments. I guess it will be easier than trying to like understand it by myself. So line 1, we declare an alias r in increasing order which match sorting closure. This improves the readability when we declare our predicate collections, because indeed it's just an alias as the name type alias suggests. We declare a collection of predicates, we covered it. We loop over the predicates. Here, 4 is the part where I was starting to struggle. Here is the tricky part, because it was indeed tricky. We want to check whether criteria can determine blog post order or not. But r in increasing order returns a Boolean. How do we check if the order is the same? Oh, this is smart, because when I had written like my framework at the time that was KeyPathKit, I had introduced an enum actually. Actually, I had used that there is already an enum in Foundation that is called NS sorting result, something like that, where you have like the 3 cases, so increasing order, decreasing order, and equality. But apparently we don't need the enum. There is a smarter way to do it. And so how do we check if the order is the same? Let's examine r in increasing order definition before we answer that question. R in increasing order is a predicate that returns true if its first argument should be ordered before its second argument, otherwise false. So 2 arguments are in equals order only if both arguments are not in increasing order. That means our predicate must be false regardless of argument order. Because since it's a strict comparison, if it's that's interesting. I guess this doesn't work when you use like that's interesting. So that means our predicate must be false regardless of argument order. In other words, left-hand side.pageview less than right-hand side.pageview and right-hand side.pageview. Oh, okay, it's because you don't swap the operator. The operator stays the same. You swap the order of the argument. I thought like you would swap like this strictly less for the greater than, but you do it by switching the order of the arguments. Okay, so indeed, if it is neither strictly decreasing nor strictly increasing, then by the excluded middle, it goes that it is equal. Okay. So two arguments are in equal order only if both arguments are not in increasing order. So this is a cool smart trick, very like algebraic trick from set theory. Really like it. Okay, and so that explains this line that I was struggling a bit about. Okay, line 5, if the order is equals, we continue to the next predicate, so the same logic we've been following before. And 6, if the order is not equals, we can use that predicate to decide the order. So it's basically the same logic, the only difference is in here. And maybe there are some hidden issues we will see. That's the result. No, actually it works. Oh yes, what's great is that since it passes a blog post, it works nicely because the blog post is already like, it's type erased implicitly. So let me explain what I mean. We pass a the closure only knows about blog post, and it's only inside the closure that we actually use the property. Because you need to understand that this operator right here, even though it looks kind of like this operator right there, they are actually two different functions because one works with like ints, another one with doubles, another one with strings. And so they're actually overloads, but they're different functions. And so Swift needs to know which function to use. And since we use the type to perform the comparison only inside the closure, but not outside the closure, this is what's called type erasure. Basically, that's what's called type erasure. It's when you use some information inside, some type information inside the closure, but it doesn't leave the closure. Like the one calling the closure doesn't need to know about it. And so that's what makes it work. And this is a super smart trick. So Wilfried, just saying not A and B. Yes, absolutely. Not A and not B is the same as not A or B. This is what's called, so in French, it's De Morgan's law. Maybe in English, it's De Morgan's law, but very famous result that you find it in logic, you find it in set theory, you find it in probability, you find it in a lot of places. And when you have that, of course, it becomes easier. And you can also, like, if you are a lot into set theory, you can draw the Venn diagram also, and it makes it easier to understand what's happening. And I totally agree. Like, this algorithm is pretty cool. To be honest, basically, like, like they say, like there are two dogs inside of you. Here, on the one hand, I'm like, this is a cool algorithm that uses a cool algebraic trick. I like it. To be honest, if I were to implement it inside an application, I might want to introduce an enum with the three cases just to make the code as readable as possible, because you don't write that kind of low-level code every day when you're an iOS developer, unless you're working on some very specific topic. And so I guess I would still favor readability over smartness. I guess that doesn't like take anything from this code. This code is still very cool, but in a real app, I would still add like the enum, because if I struggle to understand it like during the live stream, like as a developer, I would probably struggle to understand it like when reading it in a code review or anything like that. So the trick is great, but I guess if it were encapsulated into an enum to have a more descriptive API, it would be even better. But the tip is great, and I really enjoyed it. All right, conclusion. Recently, I just came across this question and found it interesting. It is a simple task that takes me some time to grasp. The methods in this article aren't tied to Swift. You can apply this to any language of your choice as long as it supports like at least like closures. And type aliases are actually not needed because they're just like a nicety, but you need to have like closures still in order for it to work. And I believe that you can improve the code to make it more generic, that support any object or property you want. And this is when you would need to explicitly make that type erasure. If you're curious about it, I actually have a video on my channel, one of the very early videos that is about, I think it's called "What the heck is type erasure?" And I think, if I remember it correctly, it uses this exact same example to show you. So if you want to see like the generic version, I actually do have it on my channel. And it says that you can share the implementation with him on Twitter, and so I will make a screenshot so I can remember to do it sometime after the live, or maybe more realistically tomorrow, because it's starting to get late in France. All right. So second article is done. Again, half an hour. So I guess half an hour is really like the metric for how long it takes to cover an article. Before we move on to the next one, I want to answer the question. So Vincent, what do you think about Flutter? Very large question. So recently, someone asked me on Twitter, should you learn Flutter as an iOS dev? My answer, which is only my answer, was no, as long as there is still demand for native iOS skills. That is like my answer, but for my personal case, that's how I kind of like the answer for my own like career trajectory, whatever, call it however you want. But that's the answer I have made myself for this choice. It still depends. Like I'm lucky to be like to have opportunities for like iOS native jobs, and there are good opportunities. Of course, if that's the case where you live, maybe the answer will be different. I know that in some countries, hybrid solutions like Flutter or React Native are more popular. In some industries, it might also be that they are more popular. So, like with many things, there is no silver bullet. But for me, I'm still like dedicated to being only an iOS developer. Like I did a training session on Flutter once to understand how it was, so I attended the training session, but never really like used it on a real project. I did some like Ionic back in the days, like almost 10 years ago, but never really like used it. So I'm very like native guy, and I still plan on staying the same for like the foreseeable future. But if you feel strongly that it's useful for you, honestly, like learn about it. Maybe it can complement your skill set. But bottom line, I guess, is that there is no like there is no truth about it. It depends on so many things. Okay, let's move on to the third article. Maybe third and final. I'm not sure. Maybe there will be a fourth one. There won't be a fifth one. That's already like out the window. I can tell you that. Maybe there will be a fourth one. Let's see. But let's go to the third one. So here we are on the blog Nil Coalescing. It's a blog that's run by Natalia Panferova. So if you follow my channel, that name might be familiar because I was lucky enough to do a video with Natalia. It was released, I think it was early November. So Natalia worked at Apple for some time. She worked on SwiftUI. She implemented some of the new APIs in iOS 16 to present models in SwiftUI. And so she, on the video, like she explained how to present models in SwiftUI, which was great because she was explaining some of the APIs that she had been working on. But she also has a blog with a lot of useful content. So as with all the blogs we've covered, I can only recommend that you check it out. If there is an RSS feed, you can subscribe to it. If there is a newsletter, you can subscribe to it. They are really like all like among the greatest content you can find in the iOS community. Is there a good blog post for unit testing combined pipelines? I don't know. I would say maybe checking out John Sandel's blog, because I know he wrote a lot about combine and unit testing. But actually, I'm not sure. I don't have anything that comes to mind like immediately. And even I myself, I'm not that big of a combine specialist. So I guess that's why I don't also know like a lot of the resources about combine. And so this article is going to be about text in SwiftUI and how text modifiers work in SwiftUI. So let's get started. But first, let me check that everything is displayed. Yes, good thing I checked, because every blog has its own layout. So I need to make sure that I am displaying everything on the screen. All right, we are good. So apart from regular view modifiers in SwiftUI, there are also text modifiers. They apply specific styles to a text view and return another text rather than some view. We can see the list of available text modifiers in the text view documentation under the styling the views text and other sections. These are the ones that have text as their return type, for example, foreground color. So I guess we've all used them at some point or another when making a SwiftUI app. So text modifiers, use cases. Oh, look at that. That bar is big, that means the article is short. So there might very well be a fourth article. Text modifiers are great for styling portions of text and can be used inside text interpolation. So text interpolation, I want to define it for people that are new to Swift, is this syntax right here where you do inside a string a backslash and then open and close parentheses, and basically it's going to evaluate what's inside the parentheses and inject it into the string. So it's kind of like if you had a string it's kind of like if you had string concatenation before and after, except that it can basically be a bit more optimized because it's Swift understand that you want to inject, to interpolate data inside the string. And also remember, if you use too many plus operators, the Swift compiler cannot evaluate the expression in a reasonable time. So to emphasize certain words in a sentence, we can interpolate text with the bold modifier applied. So this means here, this text is a view in SwiftUI, you pass it a string, and if you want some parts of the string to be in bold, you can interpolate, pass in another text with the bold modifier applied to it. So this is super cool. And what's amazing is that I was about to say it's kind of like an attributed string, except that it's a more simple version of an attributed string because all of the attributes are statically defined. Here you see that there is only this part that is bold. Like you cannot say, okay, I want all the words that are 4 letters to be bold. You can do that with this syntax. However, the syntax is simpler. So it's great to see that. I hadn't planned it at all, but all the free articles have this notion of going from something that is a static number to a dynamic number. They have this like dimension inside of them. And so this is the result you get when you display this text view in SwiftUI. We can also use text modifiers to apply specific styles to links inside text views. For example, to add an underline. So we have the text for information visit. So here it uses the fact that since iOS 15, if I remember it correctly, text can parse markdown. So it parses this markdown syntax, and then by doing underline, it gets underlined. Notice that it's not this modifier that adds the blue color, it's the fact that it's a link that adds the blue color by default, but the underline adds the underline as you would expect it to. Note that foreground color modifier won't work in this case. To change the color of links, we should apply tint on the entire text view or interpolate an attributed string with foreground color attribute. Link color is only customizable on iOS. For more tips about styling links, check out my previous post, customize the style of links embedded in text. So it shows that customizing text is always a bit of a complex topic that requires some expertise and some know-how about how the API works. Okay. As well as with text interpolation, text modifiers can be used to style portions of text combined by text concatenation. So we have text, some verbatim, then dot foreground color purple. Okay, and then plus. So we concatenate this text right here with this text there. And it seems to serve the same purpose than when we were just using string interpolation. So it's kind of the same thing, but with a different syntax. We should always prefer text interpolation versus text concatenation for localizable text because it supports a flexible order of words in a sentence, but it's fine to combine text views with a plus sign when it's not going to be localized if we find it more convenient. And here is the case because you can notice that before we are just passing a string to the text, but this time there's a difference. The argument has an external name, verbatim, and when you call the init of text that takes this verbatim string, it means that SwiftUI won't attempt to localize this string. And so in this case, the text cannot be localized. All right. if we accidentally use a view modifier instead of a text modifier with text interpolation or text concatenation, we will get a build error when we try to apply foreground style instead of foreground color. So foreground color is for the text, and foreground style is for just any view, any kind of view, I guess. So if with the example above we call foreground style instead of foreground color, Xcode says cannot convert, or actually it's written down there, cannot convert value of type SomeView, because this is a view modifier, so it returns SomeView to expected argument of type text, and so a text modifier returns explicitly a text, whereas a view modifier just returns a view. So you're asking what is verbatim for? So it means that this SwiftUI won't attempt to localize that text, basically. So the text won't be localized. It will be displayed as is. It will be displayed verbatim, hence the name of, hence the external name for the argument. And this happens because foreground style returns SomeView and not text. And I guess by reverse, it explains also why we have these modifiers that only applies to text and returns the text. It's so that we can have this nice little syntax. Okay? Combining multiple modifiers in one. If we want to combine multiple text modifiers in one to make our code more readable or to more easily reuse it in different places, we can extend text with a function that has text as its return type. For example, if we need to make some parts of the text italic and bold at the same time, we can define bold italic method on text view. And so basically we are chaining the text modifiers, and we can see that we can still return a text because each of these things returns a text, and so we can call the next text modifier, etc. We can then use that newly defined text modifier anywhere we can use standard framework ones. So it means basically that we can create our own custom text modifiers. Creating text modifiers is not something that is like the privilege of Apple when they define the SwiftUI API. It's accessible to everyone thanks to Swift's extension mechanism. And it's the end of the article. Okay, only 11 minutes. It was a shorter article. I guess for the future edition of this live, I will still not read the articles before, but I will check the length so that I can put, like one long, one short, try to orchestrate it a little bit better so there is a bit more of rhythm, like after a long article, a shorter one. But it's great to see that a short article can be read much faster. Do we have a Patreon or Tipeee or similar? No, I do not for now. I focus mostly on sponsors, actually. So if you want to support, the best way is just to share the content either on Twitter or on LinkedIn, because the most it is shared, the more views there are, and the more the content is attractive to sponsors. And so that's basically the way I'm going about it right now. Maybe it will change into the future. I don't know, but for now, that's the strategy. What can I say else about this article? No, I think I've said everything I wanted to say. So I will move on to the next article. Before I move on, fair warning: the next website does not support dark mode. So if you are watching in a dark room, expect to see the brightness level augment in 3, 2, 1. Woo! It's brighter. You can even see even the lighting on my face has changed. So I'm going to lower down the brightness of my screen a bit. So we are on the blog of Ole Begeman. I hope I pronounced it correctly. Let me put it so that it's all readable. And this one is about understanding SwiftUI view life cycles. I've seen this article on my Twitter feed some times ago. It was at the end of last year, and I was like, I'm going to save it. I never took time to read it, and now is the perfect time for me and for all of us to read it, because I had this thing that is the kind of article that probably covers some things that are not that well known about SwiftUI view lifecycle, or maybe that you know them, but you never formulated them that way. But since SwiftUI view lifecycle is basically one of the building blocks of SwiftUI, knowing as much about it as possible is definitely something you want to do when you are an iOS developer developing apps in SwiftUI. So what is Ole saying? I wrote an app called SwiftUI View Lifecycle. I wrote an app called SwiftUI View Lifecycle. I can start to feel like starting to feel that I'm getting tired because we're getting closer and closer to the end of the day in France. The app allows you to observe how different SwiftUI constructs and containers affect a view's lifecycle, including the lifetime of its state, and when onAppear gets called. The code for this app is on GitHub. It can be built for iOS or for macOS. Alright, so we have some screenshots of the views of the app, and it seems like it shows like how views behave when you use them inside SwiftUI. Okay. The view tree and the render tree. When we write SwiftUI code, we construct a view tree that consists of nested view values. So that's basically what SwiftUI calls the body of the views and of the scene at the top level. Instances of the view tree are ephemeral. SwiftUI constantly destroys and recreates parts of the view tree as it processes state changes. And this is very cheap because views are just struct in Swift, and structs are cheap to create because they are basically like very simple types with some simple semantics, meaning that in terms of memory management, it's easy for the compiler to optimize for their creation and destruction. The view tree serves as a blueprint from which SwiftUI creates a second tree which represents the actual view objects that are on screen at any given time. The objects could be actual UI view or NSView objects, but also other representations. The exact meaning of on-screen can vary depending on context. Chris Heidoff likes to call this second tree the render tree. The link points to a 3-minute video where Chris demonstrates this duality, highly recommended. I guess it's a link to the website objective-c.io, which I can highly recommend that you also check out. The keyword objects here is important because whereas in the view tree we have structs which are cheap, in the render tree we have objects, meaning we have instances with a state, with a lifecycle, and these instances are much more costly. The render tree persists across state changes and is used by SwiftUI to establish view identity. When a state change causes a change in a view's value, so like when one of your addState property changes value, for instance, SwiftUI will find a corresponding view object in the render tree and update it in place, rather than recreating the new view object from scratch. So you can see it like if a string changes somewhere in a nested view, SwiftUI is smart enough to know that only that string has changed, and so only update like the UI label that is backing the text view you've been using in SwiftUI. That is meant to be understood on a conceptual level because actually text is not really backed by a UI label. I think SwiftUI has its own text rendering layer, but you get the idea. Okay, this is of course key to making SwiftUI efficient, but the render tree has another important function. It controls the lifetimes of views and their state, and which makes sense because by definition, a struct doesn't have a lifetime, doesn't have like an identity or anything. It's just a value. So it's just like if you say like for how long has been the number 2 alive, the answer is the number 2 has existed for as long as someone has been able to think about it in a way, but it doesn't have like a specific like lifetime to it. It's just an ID. It's just a concept. So view lifecycles and state. We can define a view's lifetime as the time span it exists in the render tree. The lifetime begins with the insertion into the render tree and ends with the removal. Importantly, the lifetime extends to view state defined with addState and addState objects. When a view gets removed from the render tree, its state is lost. When the view gets inserted again later, the state will be recreated with its initial value. The SwiftUI View Lifecycle app tracks 3 different lifecycle events for a view and displays them as timestamps. So we have addState, when the view state was created, equivalent to the start of the view's lifetime. onAppear, when onAppear was last called. onDisappear, when onDisappear was last called. And this looks like this in the app. Okay? The app allows you to observe these events in different contexts. As you click your way through the examples, you'll notice the timing of these events changes depending on the context a view is embedded in. For example, an if-else statement creates and destroys its child views every time the condition changes. State is not preserved. A scroll view eagerly inserts all its children into the render tree, regardless of whether they're inside the viewport or not. All children appear right away and never disappear. A list with dynamic content using for each lazily inserts only the child views that are currently visible. But once the child view's lifetime has started, the list will keep its state alive even when it gets scrolled off screen again. OnAppear and OnDisappear get called repeatedly as views are scrolled into and out of the viewport. So when you have an if-else, when the condition changes, the views are added and removed from the render tree. A scroll view puts all of its views on the render tree even when they are not displayed and even when they might never be displayed. So the scroll view has an eager behavior and definitely not a lazy behavior. And the list, it's a bit more subtle because it's lazily inserting elements in the render tree as they appear, but it never removes them, which is different than how a UI collection view, for instance, behaves in iOS because it's recycling the cells as the element gets outside of the viewport. And the viewport, by the way, to define it, it's the part of the view that is visible on the screen of your device. So everything that is off screen is outside the viewport. Everything that is on screen is inside the viewport. You don't always, I don't know if Apple uses the name viewport actually I don't think they do, but it's a name that's very common inside in the web documentation, in the web world, so I guess that's why they are using it, but I'm not sure whether Apple uses viewport or as a name or just never mentions it in their WWDC videos and documentation. A navigation stack calls OnAppear and OnDisappear as views are pushed and pop. State for parent levels in the stack is preserved when a child view is pushed. So this is similar to how UI navigation controller works. A tab view starts the lifetime of all child views right away, even the non-visible tabs. OnAppear and OnDisappear get called repeatedly as the user switches tabs, but the tab view keeps the state alive for all tabs, and I think it's also the same behavior for UI tab view controller. You pass it an array of already initiated UI view controllers. Okay, so you're saying, yeah, same thing. I was surprised. When I gave SwiftUI training session last year, I did a chapter about performance, and so showing how list VStack and lazy VStack work relative to each other. And indeed, you see as you scroll down, if you put a print in the init, you see the print being called in the init, but they're called only once, and they're never called again when you scroll up. So you can you can measure it that way also. And you were asking what's the viewport? Perfect. I hadn't seen the message because it's under the window, but perfect that I had answered it when you had asked it. All right. And so what are the lessons? Here are a few lessons to take away from this. Different container views may have different performance and memory usage behaviors, depending on how long they keep child views alive. OnAppear isn't necessarily called when the state is created. It can happen later, but never earlier. And so that's why the good practice is to put all the side effects, all the costly things in OnAppear and not inside the init. And also, OnAppear could never be called even though the init has been called. OnAppear can be called multiple times in some container views. If you need a side effect to happen exactly once in a view's lifetime, consider writing yourself a onFirstAppear helper as shown by Ian Keane and Jordan Morgan in running code only once in SwiftUI. Okay, I'm going to add that for the waiting list, maybe for the next edition of this live stream. And finally, I'm sure you'll find more interesting tidbits when you play with the app. Feedback is welcomed. That was also a great short article because we've learned a few useful things. We've also learned that we need to be aware of how the life cycle of SwiftUI View works. But all in all, this article packs a lot of value in quite a short length. So great job, Ole, on that blog article. And since it was also quite short, I guess we can do the last one. So there will actually be a fifth article. So I will have covered all the articles that were inside the links. And so the last article, it's from Emerge Tools. So we are back to an article that does support dark mode. So I can put the brightness of my screen back to the level it had before. All right. So maybe you've heard about Emerge tools. If you were following iOS memes last year, you probably have, because they were the big sponsor of iOS memes last year. And once again, a big thank you to them. And the reason why I chose to include them in this live stream is not because they were the big sponsor last year, but rather because they published a very interesting article last year. So on the 25th of January, maybe you've seen it on Twitter because a lot of people like share this article. It was about the fact that when you use as question mark or as exclamation mark in your iOS app, it actually has an impact on the performances. And so the Twitter thread explained it, and I guess this is what the article is also doing. Let's get started. Before we get started, fair warning, if you are still new to iOS, this is an advanced topic. From what I understand in its redaction, if in the writing of the article, if I remember correctly, the people that work at Emerge Tool, there is someone that worked on the linker at Apple. So we're going to talk about some advanced topics, some topics that are challenging, even like for me with my experience. So if you're new and you feel completely lost, it's absolutely normal. We are on a very technical and on a very high level article. Yet I will try to still make it as accessible as I possibly can. So let's get started. How do you reduce the size of the app ID for a video? Oh, it's an ID for more than a video, because yeah, I can tell you, if you have startups like Emerge Tool that can like have a business model over it because of how complex it is more complex than just a video. But maybe like one day doing a video like with Emerge Tools, with someone from their side, or to show like their tool, why not? I guess it would be nice. And maybe I could take a look like if there are some like easy approaches to reduce the app size, some that are more like simple than the ones we're going to see that are like very custom and very like technical, maybe even too technical for me. Let's see. And let's drink a bit before. All right. The Swift runtime executes a protocol conformance check when you cast a type to a protocol, such as with as question mark or as exclamation mark. So these two operators, they are the two operators you can use to check at runtime whether a type conforms to a protocol or is a subclass of another type, and if so, be able to cast the value and use it with the type that you were checking. If you want more detail about how as question mark or as exclamation mark work, I also have a video on my channel about it. This one is more recent. I think it was from like last June, so earlier last year, and you can check it out. This operation is surprisingly slow, as detailed in my previous post. In this article, we'll look at an easy way to speed this up by 20% without making any changes to your source code. First, a brief review of protocol conformance checks. Yeah, exactly. That's an example, like removing assets and downloading them. So using what Xcode calls what's the name for it in Xcode? I think there is an article on NSHipster about it. I've forgotten the name, but there is assets inside of it. And yeah, Xcode has a built-in mechanism where you can say, okay, this file won't be in the bundle of my app, but it can be downloaded, and the file will be hosted by Apple on their backend. And it's pretty great. Like for instance, if you make a game and you don't want to download all the assets for all of the levels when the user is installing your app. All right. So review and iOS 16 improvements. Records of every conformance you write in source code get stored in the text const section of the binary in a form similar to this. So I was thinking we're getting into some like technical stuff. So what is the text? So here I'm going to marshal all my memories from being a computer science student. If I remember it correctly, inside a binary that is compiled with the MACH, so MACH standard, you have several segments in the binary. And the text segment of the binary is where is the code that will be executed by the OS running your program, hence the name text. And if I remember it correctly, you have several segments. So you have the text segment, you have the data segment, which is like for the global variables. And I think there is a third one, which might be the const or the static. No, it's not the static, but there is text, data, and I think there is another one, but I don't remember. I don't remember it. This is why you say that. This is why you see that I am not super knowledgeable on the highly technical parts of how you build an iOS app. But what you find inside this text segment, it is conceptually similar to this struct. So protocol conformance descriptor, protocol conformance descriptor. You have an offset to the protocol definition, so where the protocol definition is stored. So when you look at low-level things, very often instead of saying address, memory address, you will see offset. So you can understand offset as like the memory address. Why do they use offset? Is because the place in memory in the RAM of your computer where your program will be installed is not known at compile time, and so the address in memory will be the base address, so the place where your program has been installed, plus the offset. That's why it's called an offset. This is what allows programs to be loaded at an arbitrary base address in memory. So we're getting into the low-level material architecture, computer science stuff. Okay, we have an offset to the type that conforms to the protocol, so nominal type descriptor. So this is what is on the left-hand side. Okay, no, it's okay. This is what happens when a type conforms to a protocol. So you have like a pointer, for lack of a better word, to the protocol, a pointer to the type, the protocol witness table, and the conformance flags. All right. A typical app can have tens of thousands of these. Many are conformances to common protocols, such as equatable, hashable, decodable, encodable. So this is what gets created when you compile your app, basically. When the Swift runtime encounters something like myvar as question mark my protocol, may not be directly in your code, common functions like string describing internally do an as question mark, it loops over every protocol conformance descriptor in the binary, plus any dynamically linked binaries. This operation is linear, meaning that if you have n protocol conformance, is going to take at most n steps to find the conformance. Sorry. Sorry. I hope your eardrums didn't bleed too much. So basically what this means is that as the size of conformances of to protocols in your app grows, the time of checking the conformance of a variable to a protocol grows linearly. In the worst case, if you need to look up a protocol conformance record for every type, that would be quadratic. Why is that? It's because you have like two nested. Thank you. It's because you have two nested loops, and so I guess because you need to like iterate over every type and then every protocol that the type conforms to. Yeah, that makes sense. Like you have a variable that is of type A, you have a value, an object, an instance of type A, and you're doing does it conform to protocol P? Then you need to iterate over like all of the types to find type A, and once you have type A, then you need to iterate over all of the protocols that type A conforms to. So like, yeah, you have your struct and you say, okay, I iterate over them. If it's the protocol, then is it also the type? So okay, I guess I understand it. iOS 16 greatly improves on this. As explained in the previous blog post, iOS 16 pre-computes protocol conformances in the DYLD closure. So that one, I don't know that much about it, but the way I understand it, it's basically like the DYLD, the dynamic linker, it's basically the part of iOS that when you start an app, its job is to load the program into memory and to give it all of the library that it is supposed to depend on. So I guess it's kind of what is called the loader when you read like books about software material architecture. I might be wrong on it. It might be a gross simplification, but I'm going to go with it because anyway, I don't have anything better to explain it. And the Swift runtime conserves DYLD before running the O of n lookup. At the time of the previous blog post, Apple had not released the iOS 16 DYLD source code, but now that they have, we can see the actual implementation in the function DYLD FRAN protocol conformance on disk. All right. This function is conceptually the same as the zconfirm library, I don't know what that is, which speeds up these checks using a hash table that maps types to a list of protocols that they conform to. So this is basically about having a data structure that is going to make the lookups faster, I guess, at the cost of occupying more space. So you are trading time complexity for space complexity. Although this improvement is in iOS 16, it's difficult to measure in practice because this DYLD behavior is disabled when running the app from Xcode or instruments. Emerge as a local performance debugging tool that works around this and can be used to profile apps that do have access to DYLD closure. Even with the improvements, there are still 3 cases where you might encounter the slow lookup. First, on the first launch after an app install or update. The DYLD closure isn't built yet, and all conformance lookup are still slow. 2. So basically, this DYLD closure, what I understand is that it's something that is like computed the first time you launch the app, and then it's cached for all of the subsequent launches. And of course, when you update the app, it's kind of like if you had a new app because the code of the app has changed. And so, like, when you publish an update to of an app, you can say that it uses a new framework it didn't use before. So the DYLD closure needs to be rebuilt. Second, when the conformance lookup results in nil, this could use DYLD protocol conformance result kind definitive failure, but a quick scan of the source code reveals it is not yet implemented. I have no idea what this means, and so I will not elaborate anymore on it. And 3, if you aren't using iOS 16, such as a user on an older OS or using Swift on a non-Apple platform, including server-side Swift. With a simple order file, we can improve the runtime of all 3 of these cases. And so this article is basically about what are these order files, which is this seemingly magical solution that lets your app load faster without having to change anything to your source code. So order files are inputs the linker. So the linker, I need to explain what it is also. The linker is part of the build toolchain. So all the programs that take your source code and turn it into an executable binary. And the job of the linker is basically to put together, to link all of the parts of your code that were compiled separately. So you could have maybe like a library that is in binary form, a Swift package, that kind of thing. The linker takes all of this, puts it together, make sure that when they refer to one another, they do it in the correct way, and then bundles this into the binary that will be run into your iOS devices or your Mac or whatever. So the linker, so order files are inputs to the linker, which make apps faster by grouping code used together into the same region of the binary. With order files, your app accesses only the memory used by the app launch code rather than reading an entire 100 plus megabytes into memory. So I guess it's about putting information together at the same place so that it's at least easy to read it sequentially. Yeah, linker issues whenever you're doing like some hybrid frameworks or stuff, like the linker issues are always like the worst. This is where you get like the crazy long error messages. Yeah, I agree with you. Like linker errors are not fun. There used to be sometimes that kind of error also in Objective C, and usually it was not the sign that you were going to have a fun day. Okay. So with other files, yeah, your app accesses, I'm reading it again to wrap my head around it. Your app accesses only the memory used by the app launch code. Rather, okay. This principle relies on the concept of a memory page size to access 1 byte of the binary. The entire 16 kilobit page is loaded. it's beneficial to have the data you need on as few pages as possible. I previously wrote a deep dive on order files. So yeah, like the RAM actually, so your memory in your computer, so whether you have 8, 16, 32, 64, maybe even more if you have an M2 Max, I think you can go up to 96 gigabytes of RAM. You can see it as a very long array, like basically that starts at 0 and ends at a very big number, but it's actually structured in pages, and so you cannot load like only like 1 byte into memory. You can only load a page into memory, and even if you only need to read like 1 byte from given part of your file, you will still need to load the entire page into memory, because this is how memory works. And of course, this is a trade-off that allows the memory to be more efficient by grouping things together. It's kind of like I don't know, like when you want to buy like butter at the supermarket, you need to buy like a pack of butter, and you cannot buy just any arbitrary quantity. You need to buy like a big pack, a small pack, that kind of thing. Also works with popcorn at the movies. You get the idea, because it's more efficient on the industrial point of view to have like predefined sizes, and it's kind of the same principle being applied this time into computer science. Okay, so keeping used memory close together is also important to improve the cache hit rate. So cache hit rate, when you have a hit on a cache, it means that the data was already in the cache, and so you saved time. And when you have a miss, is that the data wasn't in the cache, and so you had to actually look at the data structure, which will almost always be more costly than looking at the cache. iPhones have multiple levels of memory caches. For example, the iPhone 7 with the A10 CPU has the following structure. So from fastest to lowest, so L1 cache 126 kilobytes, L2 3 megabytes, L3 4 megabytes, RAM 2 gigabytes, and NAND, which is like the flash storage, 256. And it's most of the time it's like L1 is like order of magnitude faster than L2, which is order of magnitude faster than L3, etc., etc., etc. The specifics of speeds are not published by Apple and vary year to year, but some benchmarks show that moving up level can increase latency by 5x. Okay, so not really maybe an order of magnitude, because an order of magnitude is like 10x, but still significant. Okay, so ordering conformances. By default, protocol conformances end up spreading through the text const section of the binary. This is because each module in an app generates their own static binary. So all of the packages that you can have, the Swift packages and stuff, when they are linked into the final app, the binaries are placed side by side. Data from different modules is not interleaved in the executable. So they are placed sequentially. And even though some parts might make sense to be accessed together, they will still be like worlds apart, because they are in two different modules. Let's visualize with the Uber app. The version we're using has 1000 plus conformance records. Yes, I'm too lazy to read that number entirely. Based on the size of text Swift 5 proto section and a 12.7 megabyte, I guess it's small b, but it should be a capital B, text const section. And so, I guess, how do you read this? So conformances in each binary page of Uber's text const section. The y-axis shows the number of conformances on each pages. The top figure is a heat map of conformance counts. Okay, so it says for each page size of memory inside the text const segment of the binary of the Uber app. That was long to say. The more conformances that page contain, the higher the y-axis will be, and the hotter it will be on the heat map. Okay. The above figure shows the number of conformances on each page of Uber's app. A protocol conformance record can vary in size, depends on details like SAT types, but the minimum size is 16 bytes. You can have a maximum of 1024 conformance records on a single page of memory. Interestingly, Uber has a few spikes where a page contains nothing but the minimum sized conformances. This might be due to code gen, such as dependency injection or network models, which creates many simple protocols in one module. There are also a couple regions with no conformances, so these ones right there where the line is flat and at 0, likely due to non-Swift code in the app. So basically good old Objective-C code or even like C++ or C code inside the app. Like for instance, Photo Room, we have some C code in the app, so I guess you would find this also in the Photo Room app. The key takeaway is that conformances are spread throughout the binary, so almost all pages will be loaded from memory when conformances are enumerated. And conformances are enumerated at the launch of an iOS app. This is the key piece of information. This is the key piece of information. I'm tired. This is the key piece of information that is, I guess, from the previous article they were referring, and that might not be like strongly emphasized, so I'm trying to emphasize it now that I've realized it. All right. Now we have the Lyft app. So similarly, the above figures shows conformances in Lyft's app, where there are no large spikes. There are about 250 conformances on every page, with the exception of one region that is likely non-Swift code. So here we can see that there are much more, we could say, like equally spread across the binary. We can apply the idea of using order files to group data onto as few pages as possible to conformances and generate an order file that moves all the conformances onto their own pages. And so this time the data is more structured, we could say. There is less like entropy. I don't know if it's a heat map, you are allowed to say entropy, I guess. And basically all the conformances are now at the beginning of the file, meaning that I'm just trying to say myself what the article will say. I will just read, I'm getting ahead of the article. The above figure shows the result of using an order file to group conformances. Each of the first 250 pages now only contain protocol conformance descriptors, with about 500 per page. Conformance records vary in size, so the number of conformances on a page is not always the same. We can see it varies a bit. With this ordering, less than half of the section needs to be loaded when performing a protocol conformance lookup. In fact, the total memory used by 250 pages is less than 4 megabytes. So in this example, they can all fit in the L3 cache of an iPhone 7. In our tests, co-locating the performances like this resulted in an over 20% decrease in protocol conformance lookup time on an iPhone 7 running iOS 15. Because of course, the order file not only migrates and gathers the conformances at the beginning of the binary segment, but also it probably lets DYLD, so the linker, the loader, not the linker, the loader know that after this part there is no more conformance, and so it's no point looking after, I guess. How does he measure and makes these graphs? I guess these graphs are made with the tools that Emerge Tools develop. But if you're curious, honestly, feel free to ask them on Twitter. They will be the ones better suited to ask. And as someone who creates content, I always answer this question. I always like this question. People have asked me probably more than 100 times right now how I make the animated GIFs, the GIFs with animated code, and I always answer it. And I'm always glad that people are interested in knowing. So my recommendation would be just ask the author, and I'm sure he will be pleased to explain it. So. Okay, we were here. Okay, where we are here, you can generate an order file that has this result by parsing the link map file. So I guess some kind of intermediary result or artifact produced by the linker when you are building your app. All protocol conformances end in MC, so you just need the Swift symbol names matching this pattern that are in the text const section. You could write a detailed parser for the structure of a link map, but a simple grep should also do the trick. So this is where our knowledge of Linux commands is being tested. So cat binary, okay, so this is the link map piped into a grep, all right, then another grep, all right. I'm not good at terminal things, so I'm not going to even try to explain what it does, but I guess what it does is it filters. I guess it filters to only get the things that end with MC at the end. This is some kind of rough attempt to explain it, but unfortunately that's the best I can. That's the best I can do. And so that's it. When you run this command, you now have your order file. You can set the Xcode order file build settings to the path of this file, or check out our docs with instructions on third-party build systems. For something this easy to make, it is definitely worth doing so. Doing so to speed up the app for iOS 15 users on the first launch after an app update on iOS 16. If you try out this improvement on your app, I'd love to hear about it. Feel free to get in touch. So he does want people to get in touch with him. All right. So this is definitely something that you think like, yeah, I would like to try it. And I guess indeed, like the change is transparent. Maybe if your app does some like already things around some custom things around the linker, maybe you want to be cautious because like this could break these custom things. Remember that maybe some binary library that you are embedded inside your app could be doing some fishy things with the linker, like security SDK, for instance, or a marketing or advertising SDK. So you want to be cautious. It doesn't mean that because it seems like seamless, it's riskless. However, like it's very very interesting as an approach. And finally, so Emerge Launch Booster. So Emerge's iOS Launch Booster automates the process of generating an order file and can do all this for you. So this is the tool that Emerge files that they commercialize. This is their product basically. While the protocol conformance optimization mainly applies to iOS 15 and the first launch of iOS 16, Launch Booster also includes many other optimizations that make apps faster for all your users. So if you want to learn more about it, I can only recommend that you check out Emerge Tools and you check out their website to learn more about what their tools are doing. All right. So indeed, yeah, it was an advanced article. This one, I'm glad I kept it for the end because I knew that it was going to be like a rough thing. Hello Mihai. So this is the end of this live. We have reached the end of the 4 articles I had planned. We are almost at the 2 hours time mark, which is like I feel like a good amount of time for a live stream. And for the replays, I will add chapters so that people can only like check the articles that interest them. For the next 10 minutes, if you have any questions, we can do a small like Q&A on any topics. While you think of questions, maybe I can tell you a bit more about what will be coming to the channel, because if you're still here after 2 hours, you deserve to know a bit more in exclusivity about what will be next. So I guess there will be another live stream like this, and I would say probably in 2 weeks. So not next Thursday, the one after. There will be some new videos coming probably next week called Swift in 60 seconds, where it should be about advanced. I mean, I say it should be like the video is already recorded, so it will be like it is set in stone. I will not change the videos, so it will be about short videos in 60 seconds or less to learn something new about Swift, like an API, maybe a keyword, something like that. Kind of like the Swift tip video I used to do in the past, but more focused and with better like production quality, because I've gotten better at doing videos since then. There will be other video about how to build your first, like I recorded one about how to build your first unit test, for instance. There will also be a new Swift quiz video, which is actually an old Swift quiz video because I recorded it like way back in September, I think, but then I didn't want to publish it because it was a talk I would do in Singapore and I didn't want to spoil the talk for the people that would attend. So I guess it will be published, and I think this video is still with my old setup with the green screen and the side angle and stuff. And that's basically what's planned for the main content for February, which is a short month. And maybe I will do also, like I've had the idea in a comment on a YouTube video. I did the live how to build your first Swift UI app, I think like 3 weeks ago now, or maybe 4 weeks ago, just before going to Singapore. And I had a suggestion about making a live about how to build the more common like UI patterns in Swift UI. So, like navigation, tab bar, modal, also like list detail on the iPad, that kind of thing. So I think I will do it because I think it can be very useful for beginners, and I want to make content that is useful for beginners because it's the people for whom like the content has a lot of impact. So I want to keep developing this. And I see some question in the chat, so let me see. So Wilfried, you're saying nice performance. Thank you. I'm glad that you have enjoyed it. I'm also very glad about this new format because I had the idea on I think it was last week on Thursday, on Friday. So I put together the thumbnail during the weekend and put it together. It was easy to put together, but I'm glad that it turned out well. That you liked it. I also liked it. I think it's a great format. I don't think I could do a newsletter that is like much better than the one that already exists, but I do think I can make one that is different. And this is an example of a newsletter that is like different than the ones that already exist. So I'm glad that you enjoy it. Also, I do send like emails sometimes. So I do have kind of a regular newsletter that is not that regular, but it does exist. So when you go to my website, swiftwithvincent.com, you have a message saying, hey, do you want to subscribe to the newsletter? So you can actually like do it and get some emails from me, like when I have something to say or when I have something interesting to share. All right. Have you seen the new pitch about observation? If yes, what are your predictions on when it will be available? The exciting part about it is that it will probably replace SwiftUI's dependency on Combine. I haven't. I must say I focus more on the propositions that have been already implemented because I can cover them because they will be part of Swift for certain. But that's a good thing. So that you mention it. So I will do a screenshot so that I can like check it out later, and I will definitely like learn about it. At a very high level, it seems to be kind of like what Flutter does with its like observables system. So I kind of see the big picture of what it would be like, but I will check out the details. Thank you for letting me know about it. I see, Wilfried, you're also interested into that. Have you seen CodeQL will soon be supporting Swift scanning? GitHub put it on their Q2 roadmap. Do you have experience with tooling like this, and how do you like it compared to tools like Sonar? Good question. Honestly, I don't think we use Sonar at Photoroom. We have tests, that's one, but we don't necessarily have like code quality tools. But I will make a screenshot of your comments and I will forward it to my colleague that focuses the most on tooling because he might be very interested to know about it. Will you perform video on Vapor? I'm afraid no, because I have little to no experience on Swift side things. But I know, for instance, Tim Condom is one of the most knowledgeable people on it. I think he works on Vapor. He's part of Vapor. So maybe I should ask him to do a video with a guest with him at some point. That's a good idea also. So also making a screenshot of the comment so I remember it. And yeah, basically, like you were suggesting exactly what I was saying. All right. Combine is bad. I abandoned it for observables. That's a good question. What will be the future of Combine? There is also async algorithms that does exist. Combine still has some of its use cases, but it's true that the picture of what is the future of Combine in 3 years, for instance, is definitely not clear cut. Definitely not. All right. I don't know if you have any other question. If you don't, so what can I say? I can say, of course, thank you for following this live. It was this first live of the new format of a live stream newsletter. If you enjoyed this format, please feel free to share the link. There will be a replay available immediately after I have cut the live, so you can share the same link if you think it can help people like around you, junior developers, your colleagues, anyone that it could be useful to. Please feel free to share the link with them. If you have recommendations for either articles or blogs in general that I could take a look at in future editions of this live also, please let me know. I'm always very curious to know about it. To let me know, like you can find like the tweets or the post on LinkedIn or on Twitter where I have promoted the live and just like write it like in a comment or in an answer to the tweet. And that being said, we are getting close to 10 p.m. So it's getting quite a bit late for me in France. I can tell you, I can start to be tired, and in the video feedback, I see myself also getting a bit tired. So I guess I will just have to say, like, well, have a good evening, have a good rest of your day, depending on where you are in the world, in which timeline you are. Thanks again for attending this live stream, and see you next time for some more content. Bye bye.